Hello everyone. I hope all of you are doing fine, right? So let's start our today's class. This is our ninth video lesson of for the class 9 physical sciences, right? So let's see a picture. Yes. So students, what you can see in this picture? Yes, students, I'm giving you 10 seconds. Just think about what you can see in this picture. Yes. So in this picture, students, we see that the energy is getting converted from one form to another form. Like this chemical energy is getting converted into the kinetic energy of the car. This electrical energy is getting converted into the kinetic energy of the car. This chemical energy is getting converted into electrical energy, isn't it? Right. This electrical energy is getting converted into light. It is getting converted into light and sound. It is converted into mechanical form. It is used to launch various type of vehicles also, right? So students, what we can say that to do any work, there is conversion of energy. Yes students, we have saw this in our previous class also, right? So now let's see one more picture. Yes students, so what you can see in this picture? Yes. So students, in this picture, we can see that there is a ball, right? This girl is holding a ball. And when this girl lets go of the ball, then what is happening? It is getting pulled down, isn't it? It is getting thrown down, right? So have you ever wondered like why it is happening that this ball is getting down and why it is moving? Wasn't it stationary when the girl was holding it? Yes, the ball was stationary when the girl was holding it, but as soon as the girl let the ball go, it started to move. So it started possessing another form of energy. So have you ever wondered what is where that energy of movement comes into this body? Yes, students? Right. So now let's learn about that. So student, there is a law of conversion of energy. Okay. So there is a law of conversion of energy, or rather we can say law of conservation of energy. Okay. Right. So we say that the chemical energy is getting converted to do work, isn't it? Electrical energy is getting into heat. It is used to produce sound. It is used to produce light. It is used to produce mechanical energy like moving of the fan. Chemical energy is getting converted into mechanical energy. It is getting converted into other forms of energy like it is getting converted into electricity also. So the energy can change from one form to another, right? And to say that energy is getting changed from one form to another, there is a law that has specific postulates that describes how the energy can change from one form to another. So students, let's now learn about the law of conservation of energy. Okay, students? Right. So the law of conservation of energy states that energy can be only converted from one form to another. Okay, students? So energy can only be converted from one form to another. It can neither be created nor be destroyed. Okay, students? So we can say that energy can neither be created nor be destroyed. It can only convert from one form to another, right? So another thing is that the total energy before and after the transformation remains the same. Okay, students, the total energy before and after the transformation remains the same, right? The law of conservation of energy is valid in all the situations for all the kind of transformation. It is not only applicable for a specific situation, it is applicable for all the situation that. Okay, students. So the law of conservation of energy states that energy can neither be created nor be destroyed. It can only transform from one form to the another. Right. The second postulate states that the total energy before and after the transformation remains the same always. Right. And the third one is that it is universally applicable. Right. It is applicable for all the situation and all the kinds of transformations. Okay, students. So now let's proceed ahead. As we saw this picture in the beginning of this class, we saw that in this case it was having a potential energy, right? So during the free fall of the object, there is a decrease in the potential energy. Why? Because the height is getting decreased. Here it was having a height of h1, but here it is only having a height that is approximately half of h1, or we can say it is h2. So it is visible that h2 is smaller than h1, right students? Yes. So when a ball is thrown down or it is left down, then what is happening? There is a decrease in the potential energy, right? But as it is being thrown, as it is getting down, what is happening? Movement is happening in it, and there is an increase in the kinetic energy. Okay students, so there is a increase in the kinetic energy, right? So the amount of increase of kinetic energy is only that much as it has lost its potential energy, right? So there is a continual gradual transformation of gravitation to potential energy. Understood students? So to sum it up in a very quick way, we can say that when the ball was at this height, it was having only the potential energy, right? But when this ball was moving down, the potential energy start to decrease, right? And it got kinetic energy in the return, right? Okay students, so the kinetic energy start to increase and potential energy started to decrease, right? So the kinetic energy that was gained by this ball is actually only that much of energy which is lost by this ball in the form of potential energy, right? So applying the law of conservation of energy, we can say that energy is neither created nor destroyed. It is only being transformed from potential energy form to the kinetic energy form. Okay students, so now let's proceed ahead. So there is a quiz for you, and the question of the quiz is, what are the postulates of law of conservation of energy? Right students? The question is, what are the postulates of law of conservation of energy? Right. Yes. So the law of conservation of energy states that first, energy can neither be created nor be destroyed. It can actually transform from one form to another. Okay, students. So the second point of this law states that the total energy before and after the transformation remains the same. And the third postulate states that this law is applicable universally. Okay, students? Right. So now let's proceed ahead. So students, here are different persons. So do you think that everyone can work at the same rate? Like suppose if I give you 2 pages to write daily, so you might be writing it in 2 hours, your friend might be writing it only in 1 hour, your other friend might be writing it only in 10 minutes. So is it that the rate of doing work same for everybody? Yes, students? No, the rate of doing work is not same for everybody, right? So what is the rate of doing work, right? So we will learn about what is the rate of doing work, right? So let's consider there are two children. Let's call him A and let's call her B. Okay, students? His name is A and her name is B, right? So they both weigh the same, okay? So the weight of A is equal to the weight of B and they start to climb by rope, okay? So both reach a height of 8 meter, and let's say that A did it in 15 seconds, okay? A took 15 seconds of time, but B took 20 seconds of time, right? So what is the work done in each case, students? Yes, students, tell me. Okay, so let's assume their weight is equal to what? Their weight is m. Okay, their mass is m, right? Or we can write w for weight. Let's write w. Weight is w, her weight is also w. So let's write it here. So the work done will be what? Work done will be force, that is weight, into acceleration due to into displacement, which is what? Which is 8 meters, right? So both have done the same work, that is 8W work they have done, right? But now let's find out who has done more work in the given time, say in 1 second. So how we will find that who has done more work? So we will divide it by the time taken. For A, it is 15 seconds, and for B, it will be 20 seconds, right? So we can see here that A has done work more faster, right? A has done more work in 1 second, right? So that is the rate of doing work. Okay, by the rate of doing work, we mean work divided by time. Okay, students, right? So now the rate of doing work, we call it as power. What we call? We call it as power, right? So the power measures the speed of work done, right? So that is how fast or how slow the work is done. It is measured by power. So how we define power? Power is defined as the rate of transfer of energy, or we can say rate of doing work. Right, students? So if an agent W is doing a work in time T, then power is what? Power is W by T. Right? So power is the rate at which the work is being done. Understood, students? So is there any problem? No? Okay, so now let's proceed. So yes, my dear students, we have saw that the power is the rate of doing work, right? So power is equal to work divided by time, right? So students, work is what? Work is said to be done when a force applied is doing some displacement, right? So work can be written as Newton meter and time can be written as seconds, right? So the SI unit of time is second. So work done can be written as Newton meter per second. Okay. So now this Newton meter per second is also written as watt. So power has been given a SI unit and that unit is watt. Okay, students. So that unit is watt. Okay. So 1 watt. So what is, how can we define 1 watt, students? Yes. How can we define 1 watt? Okay, so define 1 watt. 1 watt is nothing but, see, 1 watt is nothing but it is just 1 joule of work being done in 1 second, right? So we can say that 1 watt of power is is being consumed when 1 joule of work is done in 1 second. Okay, students, right? So now let's proceed ahead. So there is a quiz for you. So the first question is define power. What is power, students? I'm giving you 10 seconds to think about it. Yes. So power can be defined as rate of doing work. Okay, students? Power can be defined as rate of doing work. Right. So SI unit of power is what? It's watt. W-A-T-T. Watt. It is named after James Watt. Right. So 1 watt is defined as what? 1 watt is defined as 1 joule per second, 2 joule per second, 3 joule per second, or 4 joule per second. So 1 watt is defined as 1 joule per second. So that is the correct answer, students. So now let's proceed ahead. Students, in your home, you might have seen your parents worry about this electricity bill, right? You might have seen your parents worrying about, okay, so now there are summers, then there will be AC running, so there will be more electricity bill, isn't it? Your parents might be worrying about it. You might have seen electricity bill in your home also. So how does the electric company or the government like provide us with the electricity bill? Have you ever thought of that? Means how they like charge how much money they will take for energy that we have consumed. Okay, so now we will be studying about the commercial unit of power. Okay, students, right? So now let's take a look at the electricity bill. Okay, students, so see here, you can see that there are some base charges also, right? So you can see these are the meter reading, right? This is the meter reading. So this person has consumed how much? This person has consumed 98114 minus 96434. How much it will become? 0, right? 11 minus 3, it will be 8. 11 minus 4 it will be 7, right? So it will be 10 minus 4, it will be 6, right? So he has consumed approximately 16, 1700, 1800 watts of power. Okay, so 1800 kilowatt hour of power, right? So this was his electricity bill. So how does the electric meter like calculate how much bill to provide? Okay, students, right? So see, you might have seen this type of electric meter in your home. So there is a counter that is running here, right? So this counter is giving you how much meter it is or how much reading it is there, right? So now, how do we calculate how much energy do we consume? So let's suppose that we have an appliance that uses 1000 joules of energy every second, right? So suppose that there is an appliance. So suppose that this is an appliance that uses 1000 joules of energy every second. Then if we run it continuously for 1 hour, then it will consume 1 kilowatt hour of the energy, right? So to define 1 kilowatt hour of the energy, we can write it as 1 kilowatt hour is equal to 1 kilowatt into 1 hour. So this equals to 1000 watt into 3600 seconds. This will be equal to 3.6 into 10 to the power 6 joules, right? So when we use 3.6 into 10 to the power 10 joules of energy, then we say that we have used 1 kilowatt hour of the energy. Okay, students, right? Yes. So now the energy that is used in household and industries and commercial establishment is expressed in the kilowatt hour. Okay, students, right? So in the monthly bill that we get, we often get reading, no, this month you have consumed 400 units, this month you have consumed 100 units, right? So this unit is actually what? This unit is kilowatt hour, right? So 1 unit means 1 kilowatt hour. Okay, students. So now let's proceed ahead. So this is a quiz for you. So in houses and factories, the power consumption is measured in what? It is measured in joules, it is measured in watt, it is measured in kilowatt hour, or none of the above. What should be the correct answer? I'm giving you 10 seconds to think about this question. Yes. So the correct answer will be what? The correct answer will be kilowatt hour, right? We have studied that in households, in factories, in commercial establishment, where we use energy in the kilowatt hour, right? Okay. So 1 unit power consumption, what does it mean? 1 unit of power consumption, it means that we are using 1 kilowatt hour of energy, right? Okay, very good, students. Now we have learned about what in our today's uh, journey till here. We have learned about the conservation of energy. We have also learned about the commercial unit of power. Okay, so let's first explain what is power. Okay, so power is what? Power is nothing but the rate of doing work, right? So what is the SI unit of power? The SI unit of power is watt. It is watt. W-A-T-T. And upon whom it is named? It is named on James Watt. So now describe the laws of conservation of energy. So the law of conservation of energy, what it states, students? Yes. So it states that energy can neither be created nor be destroyed. It can just transform from one form to another form. Right. So what is the commercial unit of power, students? It is 1 kilowatt hour. So how we can define 1 kilowatt hour of power, students? We can define 1 kilowatt of power as if we run a 1000 joule of an appliance of that uses 1000 joule for 1 second for 1 hour, then it will the resulting energy will be approximately equal to what? It will be equal to 1 kilowatt hour. Okay, students, right? Okay. Now let's take a close look at our homework. So you need to take a close look at the electric meter installed in your house and observe this feature, like take the reading of the meter each day at 6:30 a.m. and 6:30 p.m. and do this activity for a week and calculate how many units are consumed during the daytime. Okay, students, so this is your activity. So students, If there is any problem till here, you can suggest me, or otherwise we can end this class here. Okay, students. So I thank you all for attending this class. So thank you everyone.